In this tutorial, I'll show you how you can perform a cluster analysis in R. To get started, upload the R tutorial script for cluster analysis. You can find this in Canvas. Download it to your computer so then you can upload it into R. Go up to File and Open File. This will allow you to search your computer for the correct script. Once you find it, go ahead and click Open. You should see what I see, cluster analysis in R tutorial. This tutorial will walk you through how to conduct both the hierarchical and kmeans cluster analysis in R, as well as visualizing them with some scatterplots. I want you to follow each step carefully and read the explanations and look for these different emojis. A little light bulb gives you a tip about what the code is doing. The siren means you need to make an edit, and the green check mark means that you can run the code without making any changes. Now you may notice that there's a lot of pound signs already in this code. A pound sign tells R to ignore the text. So this is how we make comments in our code and how I will give you instructions throughout the tutorial. To run any code in R, you need to highlight your code and click the Run button up here in the top right-hand corner of your script window. Let's move on to our first step. The first step in our cluster analysis is to prepare our data. And the first step is actually something that we're going to do in Excel. This can be done in R, but for this class, I want you to prepare your data in Excel. The first step is to make sure that you only have 2 columns of quantitative data. You also want to reduce your overall sample size if your data set is larger than 1,000 and remove any missing values. Once your data set is clean, you can then upload it to R. Just as a heads up, not all the data sets in our class will require reduction and cleaning. So it depends on if you're using a bigger data set and whether or not it's been cleaned before on whether or not you need to do this step. Either way, it's important that you save your data as a CSV file. Now, the next step is to upload our data. In R, we can upload our data with a read.csv command and file.choose. It will then assign the name my.data to your data set. Go ahead and highlight this line and click Run. What you'll notice is down below, there should be a little window that pops up to select your file. Click this. Now you can search for your cleaned dataset clustering on your computer. Once you find it, click Open. Now notice that over here on the right-hand side, something's happened in my environment window. It says my data, 300 observations in 2 variables. That's great. That means that I've done this correctly. If I want to view this data set, I can click the little play button here and I can see my 2 variables. If I double click it, it will open up a table so I can see my different variables, age, and income from the PUMS data set and my random sample. I can sort this data if I want to by using the little tabs above and look at it. Otherwise, I now know that my data is uploaded and it's called my.data. The next step, step 3, is to reassign our variable names and call our variables. I can make this window a little bit bigger so we can see the instructions and run the code. Essentially what this code does is that it's going to make the process easier for us later down below, where we can all use the names X and Y for our 2 variables. My unique variable names are age P and PINCP, age and income of Oregonians in my random sample. This code can be read as my.data, so that's my overall data set, and the little $sign tells R to look in my.data for my variable age P. The arrow tells R to assign this variable the new name X. So in your analysis, you're going to need to change this variable name. I recommend this is how you do it. Delete my variable name, put in a $sign, and what you'll notice is that your data variables will pop up down below and you can select them by clicking on their name. Of course, you can also just type the name, but this could increase the chance of you making a mistake. Now to run the code, I highlight and click Run. Over here in my environment window, I see that I have now X and Y. Scrolling down, I want to create a quick plot of X and Y. I can do that with this easy plot command and don't need to make any changes. Running the code, I can see a scatter plot of my data. I can open up the window so I can see how this looks. It's a little bit ugly, but that's okay because I can quickly see my data and notice that I've chosen correct variables. They're both quantitative, and I can see that there's really no linear pattern between these 2 variables. We're going to create a better plot when we actually do our clusterings, but ultimately we'll use the command plot again with some additional aesthetics. Now moving on to step 5. This is our last step in preparing our data. Here we want to standardize our variables. If we look at our scatter plot, we notice that the dimensions are very different from each other. So it's always important to scale and normalize our data. We can do that with the scale command. Scale my data, and I'm going to rename that mydata.scale. And now click run. Now we're ready for part 2, creating our hierarchical cluster analysis. The first step is to create our distance matrix. We can put in our scaled data, and I've chosen the method Euclidean. This is something that you can change later. Highlighting the code, click Run. Once I create my distance matrix, I can move on to performing the clustering with hclust. So hclust will create the hierarchy and the clusters that we need in order to create the dendrogram. It doesn't quite create the clusters yet because we need to cut the dendrogram based upon what we see. So highlighting this line of code will help us create the dendrogram. I'm going to use the linkage method complete. You can also change the linkage method to ward D, single, average, or centroid in further hierarchical cluster analyses. Go ahead and run this, and we can see HC pops up over here in our data environment window. Scrolling down, we'll create our dendrogram so we can analyze our clusters. Highlighting this plot, we don't need to change any of the code. Click Run. Now the dendrogram comes up in the plot window, but we can see that it's overall pretty squished. So let's go ahead and extend this window. Now looking at the dendrogram, we can see that there's one big cluster here and a very small cluster here. So if we chose 2 clusters, it wouldn't be very informative because most of the values would be in this one big cluster. It actually looks like we have a couple of little nestings down here below. So overall, it seems like maybe choosing somewhere between 6 and 10 clusters might be a good way that we can see some distinction between our data when we used this distance method and this linkage method. So coming back to our original data, let's go ahead and choose our number of clusters. Scrolling down, this is step 4. To choose the number of clusters, we can change K. Let's suppose I want to start off with K equal to 6. Then I can highlight this code and it will cut my dendrogram tree so that I have 6 different clusterings. Now this next line of code will change the clusters to a specific name and save them to my original dataset. This will be important as we create new clusterings. Highlighting this data, run again. Now I should be able to see that clustering in my original data. If I click my.data up here in the environment window, I can see my first cluster analysis. I can see that the first row represents a person who's 72 years old, has an income about $37,800, and they're in the first cluster. Going back to my script, I can now visualize this on a scatter plot. That's step 5. Highlighting the data, click Run to plot your data. Now I can see my 6 different clusters in my scatter plot. Overall, what I see that we have a younger group with low to moderate income, a middle-aged group with low to moderate income, and a higher age with low to moderate income. Then we also have a cluster that is higher income, but it's not distinctive on age. Then we have 2 higher clusters that have higher amounts of income, with one of them being a singleton. Now, something that you should take note of is the names here in our scatter plot. These all say change me. It's important that you change these for your final report. To change a plot name, you can highlight the name that you see within the quotations and just change the text. Now notice how I've changed my main titles to AHC Cluster, Analysis of Income by Age for Oregonians. I've also added in the distance measure that I used for my distance matrix and my linkage method, complete linkage. I've changed my X label to age and my Y label to income in USD. I can re-highlight this plot, run the code, and you can see that my names have changed. Now, for your project, I want you to take a look at your clusters. If you want to change some things, that's great. You should create another AHC by editing one or more of the following: distance measure, the linkage method, and the number of clusters. Be sure during the second analysis that you just rename your clusters. I'm going to illustrate how you can do that now. Scrolling back up to the top, my first step is to change my distance measure in the distance matrix. So I can change Euclidean to Manhattan, and I'm going to do that now, typing in Manhattan for Euclidean. Now I can run my new distance matrix. Scrolling down, I'm also going to change my linkage method. I'm going to go from complete to word D. Once I change the name, I can rerun my clusterings. Now I need to view the dendrogram again. So I'm going to plot my new dendrogram and visualize it in the plot window. This time my dendrogram looks a lot nicer. I can see that there's mainly 3 big clusters. I could also cut this a little bit lower on the dendrogram and maybe go with 6 clusters again. I'm going to practice changing the number of clusters to 3 based upon what I see here. Scrolling down, remember I can change the number of clusters in this line by changing K from 6 to 3. Highlighting clusters, I will reassign this name. Now the last thing I want to do before I move on to visualizing it is I'm going to change my name of my cluster analysis to hc.cluster2. This way I don't overwrite the clusters from my first analysis. I'm going to highlight this and click Run. Now I can see in my environment window that I have a new clustering in my .data, ahc.cluster.2. Scrolling down, I can now visualize this by changing the name in my plot from .1 to .2 for my ahc.clustering. Now I want to also change my distance method names in my titles. Once I change the names there, I can highlight my plot and rerun. Now looking at this cluster analysis, I think it looks a little bit simpler than the previous one. We have just 3 different clusters rather than the 6, and so it might be a little bit easier to describe. Whether it's informative enough, we'll still need to decide. If you want to look back over your different plots, you can click this back arrow so that you can see the different clusterings. This way you can make an easy comparison between your different analyses. Scrolling down, we'll start our kmeans cluster analysis. Luckily, kmeans is really simple in R. We can define the number of clusters that we want by defining centers. Here it's defined by 5, so I'm going to create 5 different clusters. Highlighting both lines of code, I'll click Run. Now I've created a new cluster analysis with 5 centers, and I've named it km.cluster.1. When I create new clusters, I will have to change this name. If I look over into my environment window, I see the name km.cluster.1. That's great. I've created new clusters. Scrolling down, I can then visualize this using the same code we've used previously. So I can highlight my plot code and click Run. Now I've created a new kmeans cluster analysis with 5 different clusterings. It looks very similar actually to the cluster analysis that I did before with about 6 different clusters. So the AHC cluster analysis and this kmeans cluster analysis are pretty similar. Now if I want to repeat this process, I can just repeat steps 1 and 2 of kmeans. This is pretty easy to do. We can go up. We can change the centers, let's say to something different, maybe 10. I can rechange the name km.cluster1 to 2, and I can highlight this chunk of code and run. Now I've created my second kmeans cluster analysis. Scrolling down, I can replot this with a basic plot without titles just to start, and making sure that I change my clusters from km cluster 1 to km cluster 2, I can plot this data. And this is how 10 different clusters look in kmeans. Maybe this is something we like better, but it definitely makes it a little bit harder to name each one of our groups. Ultimately, I just want you to be a data explorer. I want you to be able to create a different cluster analysis that makes the most sense to you. Create a good plot with titles and axes, and once you're finished, you can either export your plots or copy and paste them so you can start your write-up for your project. Hopefully this tutorial better helped you understand how to perform a cluster analysis in R.